Good afternoon, ladies and gentlemen. My name is Unju Jung from HKi노엔. As the previous speaker said, we have a different vaccine product. We are utilizing recombinant vaccine measure, and let me brief you on what kind of technology we have been developing and adopting. So, because many of you might not have heard about our company name, let me introduce the name first. InnoN is a short for Innovate New and Next. And we were once included in the CJ group, and then now came back to the Hyungwon group. And we would like to become a leader of fewer core businesses in the pharmaceutical fields, and we would like to actively adopt growth engines for a better future and to create high values. Currently, about 150 researchers work at our R&D center, and we have biologics research segment and chemical evaluation and analysis development, and each center has these subgroups. And our center also provides biologics-based product development. Now, moving on to the manufacturing site, we have largely four main facilities, and biologics is located in the Icheon plant, and other chemical or imported materials are divided into Osong plant and a Deso plant. And regarding biomaterials, it can be segmented into three different categories. First would be infectious disease, and next is cancer and oncology department. And these two areas are collecting different technologies. And since we started biologics business since 2010, we focused on infectious diseases even from then. And four materials are being tested, and one of them is now going through a clinical test. And another area I would like to talk about today, which is virus and viral vector, it is also going through a clinical test. And we also have many antiviral clinical studies, and we are discovering these as oncology treatments. And as a new growth engine, we are developing a cell therapy, gene therapy area, and we are going through the discovery stage to identify some of the materials utilizing different centers. And by doing this, we would like to make sure that a combination therapy research projects are being offered and provided. So among all these projects that we are embarking on, I would like to focus on COVID-19 vaccine development status. Of course, we can't share every single data with you, but I'm going to make a summation for our audience today. As you all already have heard, a viral infection, let's say you are infected by a material, there are three different main reactions happening in human bodies. So what you do is you first identify the material coming in, and then T cell reaction or other immuno reactions occur, and then what happens next is creating antibody for recovery. So that is why a vaccine utilizes MOA, and you basically educate your cells and your body mechanism so that when the virus actually comes into your body later, you can successfully react to it. So it's a pre-training, pre-processing mechanism. And in the case of COVID-19, as recommended by WHO, I think this current vaccine option is going to be successfully preventing other variants and mutations of COVID-19. And in order to increase the request and the reaction of T cell, we need various recombinant protein technologies. to be adopted. And because previous speakers mentioned pipelines a lot, I'm going to skip this part. If you look at recombinant protein vaccine, I know that many of the materials are usually viral vector that are going through last phases of clinical studies. You might think that the development phase is much slower in this part. The reason why this is happening, the reason why recombinant protein vaccine is made slowly is because you have to take a lot of time in the initial phase. And once the pre or early stage clinical stages go smoothly, then the later part becomes expedited. Sorry, because I'm wearing a mask, maybe my sound is not so clear, so please understand this limitation. So now, when you use recombinant protein vaccine, you have to utilize specific antigen. When protein involves an infection, and you have to choose and select antigens that can effectively respond to those foreign materials. And for COVID-19, we use a lot of spike proteins, and you have to understand whether it's full representation or specific representation of spike protein. Depending on these options, you can come up with different options. And either you use viral vector or the total virus inactivation. There are many different patterns that you can use as antigen candidates, and as a result, usually immune booster, which is adjuvant, is necessary for this type of protein vaccine. And in terms of that, there are commercial adjuvants, and most well known will be Allen. And for the US, there is CP, Terra, Line A Boost. These are some options, and GSK is offering AS series through various formulation. And these adjuvants and antigens are going to be mixed and joined and combined, and then they will go to human bodies. And there are two expected reactions. One is humoral immune response, and also you can boost immunity of physical cells. And by doing so, the same immune reaction could be induced and encouraged. And in order to produce these vaccine lines, because you have to use a specific animal cell, the lab environment is quite tricky to manage. But because these are most commonly used and widely accepted and adopted measures worldwide, you can utilize existing facilities more than any other options. And also, as you add adjuvant formulation, you can also induce broader immune responses in human bodies. And because it only reacts to specific antigen, cost effectivity is relatively high too. So moving on to the next slide, for a recombinant vaccine platform, there are many different adjuvant combinations are offered to enhance T cell immune response. There is eventually our main goal is to increase T cell immune response, but there are many different lipid structure, and pretty complicated structure is laid out, so this could serve as a disadvantage. So currently, if you only look at recombinant COVID-19 vaccines, you can see that aside from Novavax, they're not going through the later part of clinical phase because, as I said, initial stage takes a lot of time and effort. And for adjuvant, alum is most commonly used adjuvant. And because alum only specifically increased Th cell response, so WHO is not recommending this option. They are saying TCHO cell responses to be induced. That is why there are some other commercial options as adjuvants. And what we have as our technology is that peptide lipid controlling mechanism. So depending on the level of control, it helps the representation and also eventually increase the Th cell response. So instead of using very complicated adjuvants, we can only use alum and as a result, can cause two main immune responses. So let me skip on some parts. All in all, I would say the most representative would be Novavax, very similar to Novavax. If you look at represented antigen, you have to look whether it's fully represented, and if that is the case, you can formulate antigen that is successful. So I think our strength is that representation is quite easy, and when we tested on primitives, you can see the T cell response was relatively high, and you can see that a central immune response was induced properly and adequately. And as I mentioned, CPP technology, cell penetrating peptides, is basically going into the cell, and you can see that technology increases the precision of attacking and targeting cells. And as a result, during the recovery, the activities became more vibrant, and thanks to the help of Alan and the other adjuvant, you can expedite and encourage the immune response. And as you know, there are many different variants, and following studies have been carried out. I think as of now, the most problematic would be South Africa. We haven't done human to iron, but for primitives, we can look at some of the studies being carried out. And for UK, it's basically the same antibody, same efficacy is secured. And for South African one, 10 times 3 efficacy was achieved. And I didn't put that data here, but because of CNI response, if you look at Indigo challenges report, there is a high survival protection rate also against South African variant too. So currently, what we do is we are planning a clinical stage 1, and we are planning 1 dose, 2 dose, and control group, and in order to go through an actual trial in Korea, we're prepping many different elements. And I know that Pfizer is out, and the efficacy of existing vaccines have been approved and showing how efficient they are. And we are going to continue to look at and refer to their results so that we can refine our vaccine development process. So, in summary, we can also tell you that we are providing and preparing technical clinical studies for other materials for co-development, and we will continue our research so that co-development can happen in the near future. This is everything from my side.